Welcome to part 3 of lesson 2 in History of Economic Thought. Today we're going to look at the merchant monopolies. Before we do, though, I want you to read this article and then fill in the words and phrases in the excerpts of this article below. In the early 17th century, England under King Charles I faced persistent financial strain, worsened by the king's aversion to parliamentary taxation. To raise revenue while bypassing Parliament, Charles turned to granting monopolies over key industries. In 1632, he chartered the Society of Soapmakers of Westminster, granting it exclusive rights to produce and sell soap throughout England. This was not a mere favor to loyal courtiers, but a calculated quid pro quo. In exchange for monopoly privileges, leading merchants agreed to remit a portion of their profits to the crown, effectively acting as tax collectors. This arrangement gave Charles a steady income without parliamentary consent, while the monopoly secured control over a vital household commodity. There are remnants of this today. When we lived in Utah, I purchased a motorhome that I used as a rental property. I would deliver it to a campground within 50 miles of Salt Lake City, Utah, set it up for my customers. My kids and my wife would stay in it the night we set it up, and then I would check it out to my client. And then we would return 4 or 5 days later. We would stay in it that night, and the next morning we'd leave. So we got to use it with our clients paying the cost of the campground, the gas to get it there and back, a security deposit. And we basically used it for free the night before and the night after. And some revenue at it. I think we were making about $15,000 a year from it. Why did I bring that up? Because in order for me to do this in Salt Lake City, Utah, I had to agree to collect sales tax on behalf of the state. So I'm kind of like the Soap Makers Society, who was allowed to conduct business in the kingdom, but in exchange for that, they had to agree to collect taxes on behalf of the king. I had to collect taxes on behalf of the state. The soap monopoly dramatically reshaped the market for a staple used across all social classes. The Society of Soapmakers gained authority to set prices, limit output, and enforce regulations, including banning independent soapmakers and confiscating unauthorized products. These powers secured their dominance but devastated small producers in cities like London and Bristol, many of whom were driven out of business. Although the monopoly soap was frequently criticized for poor quality, consumers had no legal alternative due to royal enforcement. Meanwhile, merchants fulfilled their tax obligations by funneling substantial proceeds to the royal treasury. While this strengthened the crown's finances, it also bred resentment among both merchants and consumers, burdened by higher prices and restricted access. In the model below, we're going to round all prices to 2 decimal places and all quantities to 3. In the following 17th century English soap market model, P is the price in pounds sterling per barrel, and Q is the quantity of soap in thousands of barrels. I clicked this already and open up the Desmos model over here. I need to change the intercept of demand to 41.35 and the slope to 0.045. And then the supply curve is 2.35 and 0.055. So I'm matching this and that to these two equations. Then I'm going to turn off the marginal revenue equation. Under perfect competition, the market clears where supply intersects demand. Click on the intersection of the two black lines to determine the equilibrium point. So the equilibrium quantity is 390,000 barrels of soap at a price of 23.8 pounds sterling. This model seems that England's early 17th soap market was perfectly competitive, with 5 identical merchants supplying a vital household good at fair prices. One of them, Merchant M, was well connected to the king and inherited his business. The remaining 4 merchants, lacking such ties, had risen from poverty to build businesses identical in cost, output, and sales to merchants. Under these conditions, the 5 merchants evenly split the market, each supplying what? If the total quantity supplied and demanded in the market is 390,000 barrels of soap, and there are 5 identical merchants supplying the soap, then each is going to supply 78,000 barrels at the market price of 23.8 pounds sterling. Therefore, each merchant is not a heartbreaker, not a life taker, not a price maker, but a price taker. They take the prices given. Facing the following demand curve, it's perfectly elastic. They have no control over price. The price is the price, 23.8. Now notice what happens to my model here. This is the market quantity, and this is that market price of 23.80. This market quantity of 390 is split 5 ways. Down here, you only see one graph, but there are actually 5. One for each of the 5 merchants. And each is faced with a perfectly elastic demand curve. They have no ability to charge a price above that, nor would they charge a price below that. They're going to charge 23.80 because if they charge a price above that, customers will flee to the other 4 merchants. They're not going to charge below this price because if they do, it's ridiculous. They can sell all they want at this price. So they're not going to sell below it and they're not going to sell above it. Since the market supply curve is the horizontal sum of the marginal cost curves of the 5 merchants, and each merchant supplies an equal share, the big Q is total quantity supplied in the market. The little q is the amount that each firm supplies. So big Q equals 5 times little q. So this right here is the market supply curve, or the aggregated marginal cost curve. To get the marginal cost curve for the individual firm, we replace big Q, total quantity supplied in the market, with what it equals. 5 firms each supplying little q. So I just replace big Q with 5 times little q. And then I do a little algebra. 0.055 times 5q is 2.75. So the slope of the individual marginal cost curve for firm I, and there's 5 firms, so there's 5 copies of this equation. They're all identical because the firms are identical. So the slope is 2.75 times the little q. The intercept is the same as the aggregate supply curve or the aggregate marginal cost curve. Oh, yeah. Sorry. I made a mistake here. The slope is 0.055. We got to multiply that by 5, and we get the slope of the marginal cost equation for each of the 5 firms being 0.275. Now, when I press enter, watch what happens to my graph here. Entering this equation draws the marginal cost line through this graph. And you got to remember, there are 5 copies of this. There's one of these for firm 1, one for firm 2, one for firm 3, one for firm 4, and one for merchant M. Under perfect competition, the merchant's revenue equals the quantity it supplies. Each merchant supplies little q, and each firm supplies the same amount because they're identical by assumption. Little q times 5 is the big Q. So this is the revenue equation of each of the 5 firms. Because each of these merchants is a price taker, they have no control over the price. The price is the price. It's 23.8. We replace P with what it equals, 23.8. The slope of this revenue equation is 23.8. This is an equation that has an intercept of 0 and a slope to 23.8. As Q increases, R increases linearly. Since the slope is the change in revenue, delta R, divided by the change in quantity, delta Q, and 23.8 can be divided by 1 to give you 23.8. What that means is if we increase quantity by 1, revenue is going to increase by 23.8. Let me show you what I mean by that. So if quantity was, say, 1, revenue would be 23.8. If we increase the quantity by 1 to 2, revenue is 47.6. The change in revenue is 47.6 minus 23.8. We're going to divide that by the change in quantity. We went from 1 to 2. So this is the change in revenue, and this is the change in quantity. That ratio is 23.8. Now, if I change this to, say, 10, then I got to change this to 11. So this is 11, and that is 10. When quantity is 11, revenue is 1061.8. When quantity is 10, revenue is 1038. The change in revenue is 23.8 because its change in quantity is 11 minus 10, which is 1. 23.8 divided by 1 is 23.8. So because this is true for any consecutive set of quantities, 100, 101, 1021, 1020, this is going to be true for any consecutive pairs of output. That makes it a line. Now, when you see the word marginal, think of the word slope. So we want the marginal revenue here. We want the slope of revenue. And the slope of revenue is 23.8. When I press enter, watch what happens to my graph here. Right now, the demand curve that each of these perfectly competitive firms are faced with is a flat line, the black flat line. When I press enter down here, watch what happens to it. It's now red because red is the marginal revenue and green is the marginal cost. Now, a merchant maximizes profit by supplying the quantity at which marginal cost just equals marginal revenue. So for merchant I, and I could be merchant 1, merchant 2, merchant 3, merchant 4, or merchant M. There are 5 identical firms. They all choose output where their marginal cost equals the marginal revenue. That will maximize their profit. MC, if you remember, is equal to this, 2.35 plus 0.275Q. So I'm going to replace this with what it equals. What does MR equal on the right side? MR is 23.8. Then I can solve this for Q to get the output level that each firm wants to supply. So I'm going to copy this to Desmos. Then I'm going to solve for little q. I subtract 2.35 from both sides. If I subtract it from the left, I have to subtract it from the right. Now 2.35 minus 2.35, well, that's a fancy way of saying 0. And 0 plus anything is anything. Now I'm going to divide both sides by 0.275. So if I divide the right side by 0.275, I have to divide the left by 0.275. 0.275 divided by 0.275, well, that is equal to 1. And 1 times Q is just Q. So notice that Q is equal to 78. That 78 looks familiar. Why? Because if you recall, the market quantity was 390. When we divided that by the number of identical merchants supplying this good, we got 78. So this is not a coincidence right here, 78. It equals the total quantity supplied in the competitive market divided evenly among the 5 merchants. In a perfectly competitive market where economic losses drive out firms and profits attract new firms, each merchant is going to earn 0 economic profit in the long run. If there are long-run profits to be made here, firms will be attracted to the market and firms will jump into this market, pulling the price down. If these firms are making losses, then firms will exit and that'll push the price up. And that'll occur until economic profits go to 0. Although merchant M, like the other 4 merchants, is earning 0 economic profit, he holds a key advantage: strong political connections to the king. Recognizing the crown's need for tax revenue, merchant M leverages his ties at court to request a royal monopoly. He anticipates a favorable response, knowing that his competitors are of low birth and that the king is eager to secure a steady stream of income. As expected, the king grants Merchant M exclusive rights to produce and sell soap, effectively making him both producer and tax collector. Without a royal license to operate, the remaining 4 merchants are forced to sell their businesses to Merchant M, who consolidates them under a new name, the Society of Soapmakers. With the Society of Soapmakers, Merchant M, now owning all 5 soap operations and facing no competition, it becomes a price maker because it can drive prices up the demand curve by adjusting output. As a result, its revenue will vary according to the following equation. The monopolist is a price maker. We're going to multiply that price, which depends on Q, times quantity. Price times quantity is revenue. Now, price is equal to 41.35 minus 0.045 Q in my model. So this equals the price. Merchant M is not going to know this equation. But what we're assuming here is the merchant has a pretty good idea what the relationship is between price and quantity demanded by UK subjects. So when we replace P with what it equals on the demand curve, we get a revenue equation that is no longer linear. Let me show you what I mean by that. But first, I have to shut off the supply curve. So this is revenue divided by 1,000 to change the scale and fit it in the diagram. At a quantity of 459.444, my revenue is not 9.49901. It's actually 9,499 because I scaled it down by 1,000 to fit it in here. I'm going to change the color to gray. Okay, so this is revenue. It rises and falls because it's a parabola. So it intersects the x-axis at 0, 0 and at the x-intercept of the demand curve. Why is that? Well, at this price of 41.35, quantity 0. What is 0 times 41.35? 0. So that's why revenue starts at 0, 0. Then it rises and falls. Why is revenue 0 at this point? Well, when 918.8889 are supplied, there's no scarcity. And so people value that at a price of 0. And 0 price times that quantity is 0 revenue. As we increase quantity and lower the price, revenue will rise, and then it peaks, and then it starts to fall again. So up here, where revenue is maximized, the slope is 0. You can actually see that if we were to zoom in. You can see this is the revenue curve. At the quantity level that maximizes revenue, the slope of the curve, if you zoom in enough, is 0 because it's a flat line when you zoom in. So what that says is at the peak of revenue, the marginal revenue is 0. At the revenue peak, the slope is 0, corresponding to the quantity where marginal revenue equals 0. As quantity continues to increase, the slope becomes increasingly negative. So now the slope is negative. So marginal revenue is positive, marginal revenue is 0, and now marginal revenue is negative. Thus, for a linear demand equation, the marginal revenue equation has the same intercept as the demand curve, but a slope that is twice as steep. Another way to think about that is if you've taken calculus and you differentiate R with respect to Q, when you differentiate the linear component, the old exponent is 1. And when you differentiate with respect to Q, you take the old exponent and you subtract off 1. So when you differentiate R with respect to Q, this becomes Q raised to the 0 power. And then you take the old exponent, 1, and you multiply by the coefficient, 41.35. So marginal revenue has the same intercept as demand. This is the quadratic part. When you're differentiating this part of the revenue curve, you subtract 1 from the old exponent. So the new exponent becomes 1. The new exponent of Q is 1. Q to the 1 is just Q. Then you take the old exponent and you multiply it by this coefficient. 2 times 0.045 is 0.090. Notice what happens to our graph here. When I enter the values, the parameters, into the marginal revenue equation, my open math draws a red downward sloping line. The marginal revenue curve has the same intercept as demand, but is twice as steep as demand. So what I'm going to do is I'm going to turn on equation 3. I got to change it. This was the default when I opened up the Desmos. It's got the same intercept as demand, but it's twice as steep. And notice right here, the height of this red line is the slope of this gray curve. The red line's height is the greatest at 0, 0. This gray curve is the steepest at 0, 0. At this quantity, 459.444, the slope of revenue or marginal revenue is 0. Up here at the same quantity, kind of hard to, maybe what we'll do is this. I'm going to copy that and I'll paste it right here. X equal, and I'll change the color to gray. Notice that this quantity, 459.44, marginal revenue is 0. Revenue's reached its peak at 459.44. The slope of the gray curve is 0 at that point. The market supply curve is the monopolist marginal cost curve. Let me turn the market supply curve back on. When the 5 firms were independent and competing against each other, 390 barrels of soap were produced and sold at a price of 23.8. The monopolist increases its price, which reduces the quantity until marginal revenue equals marginal cost. So the output that maximizes monopolist profit at the intersection of the red marginal revenue curve and the black marginal cost curve, also known as the market supply curve, which is 268.96552. I'm going to copy that, Control C. Because this fourth number is 5, it makes that 5 on the left of it 6. I'm going to press enter to make sure I got it right. Notice what happens to the graph here. It draws in a dashed line at the quantity where marginal revenue equals marginal cost. Lowering output to this level allows the monopolist to push the soap price up the demand curve to the monopoly price. To find this value in your Desmos.com worksheet, change x equals 0 in line 4, copy this value from my open math, and replace a 0 with it. So reducing output to this quantity level means the monopolist can charge a price equal to 29.24653. We need to round that to 2 decimal places. So because that is a 6, that is a 5. Let me press enter. Notice what happens to the graph. Now the dashed line is drawn straight up to the demand curve and then bounces off the demand curve and goes to the price 29.25. So what the monopolist does is it just raises the price until marginal revenue equals marginal cost. To achieve the monopoly outcome, Merchant M will do what? Keep all factories open and decrease its price? No, it doesn't want to do that. That will reduce its profit. Shut down some of the purchased factories to reduce the price? It doesn't want to reduce the price. Sell acquired factories to highest bidder? Well, if it sells factories to highest bidder, those factories could be reopened and maybe sell soap in the black market, so it's not going to do that. Shut down some of the purchased factories to reduce output? That is probably the best answer of the 4, because that allows it to reduce output, which allows it to raise the price. The soap monopoly became emblematic of broader grievances against Charles I. High prices, limited output, and the king's protection from competition stripped consumers and former producers of alternatives. They grew resentful. The quid pro quo agreement, in which favored monopolists enriched themselves while taxing the public, came to symbolize royal corruption and overreach. Combined with other unpopular policies, these economic injustices fueled growing discontent. By the late 1630s, the soap monopoly had become a lightning rod for opposition to the king's arbitrary rule. It was abolished in 1641 by the Long Parliament as public and political resistance to monopolistic abuses intensified, contributing to the rising tensions that culminated in the English Civil War. As you read this article, fill in the words and phrases in the excerpts of this article. Do the same thing for this article that is tweeted in this X thread. Do the exact same thing for the pacificlegal.org article that has been tweeted in this X thread.